Hello class. Today we're going to begin chapter 10, which is our chapter on circles. Today's focus is actually section 10.1, which is tangents to circles. The first vocabulary term is circle, which I know most of us are aware of that term. We've heard of circles many times before, and we've talked about them in class. The definition of a circle is the set of all points in a plane that are equidistant from a given point. So as you're looking at your circle, that given point being the center, every point that's on that circle is the exact same distance from that center. The term radius is going to be the distance that goes from the center of a circle to a point that's on the circle. It's a segment. It is not a line. It has two endpoints. That measure that I've marked right here on this picture would be called my radius. We all have heard of that vocabulary term before too. A diameter is what we're talking about when we talk about a segment that contains two endpoints that are both on the circle, but it also contains the center of the circle as well. It's the distance across that circle going through its center. It's also a segment. It is not a line. It has two endpoints. When we're talking about two circles being congruent, we'd be talking about two circles that have the exact same radius, because all of their measures would then be the same as well. A chord is a segment whose endpoints are on the circle. So notice that when I'm drawing the segment here, both of those endpoints are on the circle. A diameter is an example of a chord, but there are lots of chords that we could draw. So anytime that you're talking about going from 2 points on the circle, you would be talking about a chord. A secant is a line that will intersect a circle in 2 points. But notice that I said it's a line. It's not a segment. So a secant contains a chord on it, but it's the entire line, would be the example of a secant. A tangent will be a line that will intersect our circle at exactly 1 point, and that point is going to be on the circle itself. So when you're looking at a tangent, you're going to see that it's going to touch the circle but only one place, as opposed to a secant that will touch 2 places. That point where our circle is touching that tangent line will be called the point of tangency. Alright, when we're talking about two circles, we can talk about how they'll intersect at 2 different points, at 1 point, or at no points. So when we say that two circles intersect at 2 points, you're going to notice they're going to have a piece that's overlapping. If they touch at just 1 point, they're not going to have any parts that overlap, but they will have that 1 point in common. But you could also have circles that will never touch. In fact, if a circle was inside of another circle, they never actually intersect. The sides of the circles do not intersect. When we talk about tangent circles are coplanar, meaning they're on the same plane, and they intersect in 1 point. So this example that I have up here would be an example of tangent circles. They're on the same plane. They intersect at exactly 1 point. Concentric would be coplanar circles that have a common center. So this would be an example of our tangent circles that intersect at 1 point. But when I talk about concentric, they have the exact same center. That center is the center of this smaller circle, but it's also the center of the larger circle. Those are concentric circles. When we talk about common tangents, we're talking about tangent lines that are common to 2 coplanar circles. So I have an example here of 2 circles. They actually don't have to be touching, but in this case they are. They have a point in common, but they also have a line that is tangent to both of them that touches both of those circles at just 1 place. When we talk about internal tangents and external tangents, the difference here is an internal tangent is going to intersect the segment that would join the centers of those 2 circles. So if I draw in the centers of those 2 circles and draw in the segment that contains those 2 centers, or that joins those 2 centers. If my tangent went through that segment, that would be considered an internal tangent. But because this tangent goes outside of the circles, that's considered an external tangent. So to draw an internal tangent with these 2 circles, it would have to be the line that would go right here, that goes through the segment that adjoins their 2 centers. So taking a look at the examples that I have up here, these 2 segments that I've drawn, these 2 tangent segments, I know they're tangents to both circles. These 2 lines of tangency are both considered internal tangents because they would connect the line